Good afternoon, ladies and gentlemen, and welcome to our Shift2Rail webinar ATO over ETCS, taking you on an interoperable journey from concept to field experience. My name is Bettina Dötsch from Thales, and I will guide you through the different sessions of our webinar this afternoon. The core of this webinar is the presentation of the results of the ATO GOA2 field testing, which took place in the second half of 2020 for passenger trains in the United Kingdom and for freight trains in Switzerland. In addition, supporting presentations will give insights in the different steps carried out to prepare the necessary equipment needed for the field testing. We will take a look at the specification of the interoperable solution, the preparation of the logo, as well as on the implementation and integration of the ATO equipment. At the end, an outlook to the future will be provided, and for sure we have a question and answer session. Whenever you have a question during the different presentations, please share them with us in the comment box. We will save these questions and then answer during our Q&A session at the end. Now I am happy to announce the first speaker, Carlo Borghini, the Executive Director of Shift2Rail Joint Undertaking, giving the keynote speech. Please, Carlo.
Good morning, Bettina. Good morning to all the colleagues. I'm really happy to be here with you today. And I think, the title of the event is self-explaining. And there's a major results that have been achieved within the context of the work we have done and the member of Shift2Rail have done concerning ATO. First of all, I think we need to thank all the people that have been working in this direction because I've been working in quite difficult situation, starting with Network Rail and Deutsche Bahn Cargo that have allowed this test happening and these results to be achieved. Both we need to thank the managers, project managers in charge of this. Catherine Stowe from Network Rail and Basilio Jacob for Deutsche Bahn Cargo. Also, I would like to thank all the people that have been working in these other activities: Alstom, AGD, Bombardier, CAF, Hitachi, Siemens, Thales, also the governments that allow us to run the test during the difficult time of the COVID. So now, so said. Well, it's not only thanking people, but I think we have set the basis for a major progress in automation. And from this point of view, is one of the major results that ATO has been achieved in the context of IP2, and is paving the way to achieve the future results for GO3 and 4. In the US, they are looking also to GO5, so the possibility for a train to decide about the switches. I don't know if we will go in this direction, but it will be interesting also to explore this in the context of Europe's rail JU. We are talking about automated train operation over ETCS that are by design providing full interoperability in the future. Clearly, this creates also an opportunity for the market and an acceleration for the market, because this work doesn't stop with research innovation, but it concerns also the input to the TSI. And for this reason, we are really happy to see that the specification that have been contributed to by X2RAIL and the work of the results of the test is part of the TSI package 2022 that we expect to be adopted next year or just immediately after, in a manner that will create an opportunity to also create an opportunity for return on investment for the supplier and maximize the performance of the rail system for the operator and also for the infrastructure manager. So this work is, as I said, is not the ending point, it's only the basis. It's clear that now we are moving towards Europe's rail, and Europe's rail automation, and I would say moving from automation to autonomy will be one of the major challenges in front of us. But as you know, many other sectors, starting with the road, have talked about autonomy in the vehicles, and I believe that rail has all the capacity, and has been demonstrated also during this test, of achieving it much faster than maybe other sectors. What is important is that is not a journey in isolation, is a journey that would allow all the European network to benefit from it and all the European operators to benefit of it, including to create market opportunities. I think it's important also that we emphasize a lot the dissemination of the activities, because we have global competition that we need to face, and the results we have achieved in Shift2Rail, that you have achieved in Shift2Rail, working together, need to be promoted and disseminated around the globe, and becoming an example of how collaboration can achieve such results. And I think we need to accelerate really on GEO3 and GEO4. If you want to achieve the targets of the sustainable and smart mobility, to double high speed by 2030 and triple, make it 3 times by 2050. If you want to increase rail freight of 50% by 2030 and double by 2050, we don't have alternatives that increase the capacity and the performance of the rail system. And this can happen only via the automation and digitalization of the rail system. We can build new lines, but they will never be ready by 2050. Never ready, most probably by 2030, maybe by 2050. So in this respect, the work that we have we are planning to do in Europe's rail together, it's a fundamental piece of work to ensure that we change the way rail is perceived by the public. This is more important also in 2021, the European Year of Rail, that has been launched formally by the Presidency of the Council yesterday, together with Commissioner Valen. And I think it's really a sign of the capacity of rail to rethink and reinvent itself. So I would like to give back the floor to Bettina, especially thanking all of you for the amazing work you have done during these months and years, including, once again, in the most difficult situation. And I hope to have the opportunity to recognize it publicly with people around the table, not only via digital conference, and maybe share a glass of wine together. Thank you very much. Bettina, back to you.
Thank you very much, Carlo, for this opening, and for thanking all the people, because I also share your view that we have done great work in these difficult times. Now we continue with Benoît Bienfait. Benoît Bienfait is the ATO system manager at Alstom, and in Shift2Rail he is the TD leader for ATO over ETCS in the Shift2Rail project. And in his role, he's driving all the specifications with the partners towards an interoperable solution. Please, Benoît, it's your turn.
Thank you, Bettina. Good afternoon, ladies and gentlemen. I will present you the background of the test that we have performed last year, end of last year, in UK and Switzerland. The background is the Shift2Rail program, funded by European Commission, as is mentioned here, and co-funded by other funding members. You can see here the main companies funding member and also associated members. The objectives of this Shift2Rail program is to foster innovation in the railway sector, also to increase the reliability and punctuality by 50%, to double the railway capacity, to contribute to reduction of negative externalities, noises and vibration and so on, to contribute to the achievement of a single European railway area, and to make the rail sustainable, cost-efficient and high-performing. And finally, the scope is also to address industry challenges, which are, next please, rising population, increased demand on mobility, increasing density in urbanization, the demand of reliable and more efficient transportation infrastructure, and the reduction of emissions and protection of the environment. If we want to summarize the target of Shift2Rail, it is to conceive the new transportation system in Europe, no more than less. Next, please. I propose now to show you a video before to continue, a video reminding the basic criterion and the basics of ATO. Please, next.
Grade of automation, or GOA, is the term used to describe different degrees of automation within the railway system. A GeoA2 system is one in which the driver initiates automatic operations and is present in the cab during any automated activity, taking over in an emergency. In an ATO system, there is an onboard system that computes the automatic driving profile. Trackside, there is a corresponding ATO system that sends the train information it needs to calculate the automatic speed profile. The ATO always calculates a driving profile within the ETCS safety limitations. Traffic management systems provide train arrival times across the journey, and the ATO drives in the most energy-efficient manner while adhering to the timetable. At stopping points, the ATO can be configured to automatically open and close doors, but crucially, the driver will always be in charge of engaging the ATO during dispatch and can take back control at any time. ATO safety. The ETCS protects the train all the time by calculating the maximum safe speed of the train at the point this threshold is approached when the train operation is controlled by ATO. The onboard ETCS system supervises onboard ATO by avoiding the train reaching an excessive speed or passing the end of authority. The corresponding trackside ETS system sends movement authority and the geographical information so that the onboard ETCS, along with ATO, can calculate the maximum safe speed. Benefits of ATO: increased capacity on the existing network, increased energy efficiency, improved recovery from disruption, better punctuality, reduced operational costs, wear and tear reduction, improved passenger comfort.
In fact, what is important to say at this stage is that what we are doing now in Shift2Rail is also consistent with previous European projects like TEN-T Innovation Program and New Generation Train Control NGTC. Already in the TEN-T program, we already worked with the users team members to produce operational concepts covering the entire signaling system with the different grade of automation for ATO. And we have already worked with the suppliers team members. We have worked on the system requirement specification for GeoA2, starting from this operation concept. And when we started Shift2Rail in 2016, we immediately started with two work streams. The first one is related to GeoA2 specification, starting from what has been already initiated in the TEN-T program, to continue the specification activities in conjunction with the agency, European agency, ERA, to produce the product, ATO onboard and trackside, to perform also IOP tests in factory, and finally to perform pilot tests last year in UK and Switzerland. These tests were based on GeoA2. And in parallel, we have immediately started also the second work stream, which is longer. And the purpose of this work stream is to develop the specification for the ATO up to GeoA4. And the specification activity should end of 2022. We have also foreseen product development, prototypes, and then similarly to GeoA2, reference test bench in factory, and finally pilot test lines for GeoA3-4. These pilot tests will be realized beginning of 2023. So with the ATO, we clearly address some of the main topics of Shift2Rail: energy consumption reduction, also line capacity increase, as said during the movie. This Shift2Rail has standardized also the interoperable solution for greater automation 2 already. And in the working group, we have the suppliers representing the industry, but also the IAMs and RU for the users. ATO is clearly a game changer, which is considered in the rollout of ETCS. In this game, the jouer two activities and solution is clearly the quick win, where we win already a lot of energy consumption and line capacity. Next. And last word on this slide, you can, next please, for the slide. Voilà. What is important to say is that for the pilot test that we have performed last year, oh please, one, you go too fast. No problem, let's continue. So this slide represents the architecture of ATO and ETCS today. You have on the left the ETCS onboard and trackside subsystems, and on the right you have the ATO and DAS, because ATO is also performing DAS, driving advisory system function. And what you see here is the list of subsets which are currently in discussion with the European agency, ERA. The sub 125 specifying the interoperable functional specification for an ATO over ETCS, and the other documents specify the interfaces between the ATO onboard trackside and the other subsystems. For example, for the ATO onboard, you have the sub 130 specifying the triple FIS interface between ETCS onboard and ATO onboard. 139 specify the triple FIS interface with the train, traction and braking interface, for example, and the 140 interface, a subset, specifies the interface triple FIS with the onboard recording device. What is important to say also is that currently for the ATO onboard, for the lower layers of communication with other subsystems on board, we refer to the subset 143, common way of work. There is also the subset 126 specifying the triple FIS interoperable interface between track and train for ATO. Once more, split in two documents, the application layer 126 and Appendix A specifying the lower layers communication. This second document shall be replaced in the future by the FRMCS new coming standard. And finally, we have an interface between the TMS and the trackside ATO, which is X2RAIL 131. Next slide, please. As we have said before, we have performed already interoperability tests in factory. The purpose was to demonstrate the interoperability of the specifications. Two reference test benches have been realized, one in Belgium for Alstom and another one in Germany, delivered by Siemens. And on these two reference test benches, we have tested the different configuration you can see on the slide now. In Alstom, you have seen, we have tested for the ETCS onboard Alstom one, the ATO onboard CAF, the ATO trackside from Alstom for the first configuration. The second configuration in Belgium was the ATO onboard from Siemens, ATO trackside from CAF, and ETCS onboard from Alstom. And in Berlin, on the Siemens reference test bench, we have tested the first configuration was the ATO onboard from EZD, the ATO trackside from Siemens, and ETCS onboard from Siemens too. And the fourth configuration, second one in Germany, is the ATO onboard from CAF, ATO trackside from Thales, and ETCS onboard from Siemens. And we have tested a lot of test scenarios. Some of them are mentioned here on this slide. Train stops at stopping point, transition from Joe 1 to Joe 2 on the move, train departs from stopping point, rerouting of a train, and stopping point skip, and this type of thing. And that has been performed in 2019, February 2019, demonstrating this interoperability. Of course, during this test, we have found a lot of findings permitting to refine the requirement or to add some requirements is missing. Next slide, please. Yeah. Some word about the next step for us up to Joe 4, the second work stream I mentioned before. For that, we are clearly more towards the future, of course, because it is quite new for everybody. And we have started, as mentioned on the left of the slide, a double approach with a top-down approach, starting from the operation context, the actors definition and use cases, very close to the operation needs. And it is a very disruptive way of work top-down. But in parallel, we have started a bottom-up approach based on of functions, copying the functions performed today by the driver, and going to the architecture via this interface specification. The two approaches are very important because the bottom-up approach guarantees that we will not forget things which are already implemented today in classical systems with drivers, while the top-down approach is more disruptive. The first stable document, set of documents for this up to Joe 4 specification is expected for May 2021. And this specification will be used as reference to the development of the prototypes that we will test in factory and then on site. And the next steps are a risk assessment starting from this specification, a safety analysis, laboratory test, also pilot test in 2023, and the final specification revision. As we have said already several times, we are now focusing on the TSI 2022. We discussed with ERA, the agency, about the Joe 2 specification. But with this up to Joe 4 specification, we are preparing the new ERA standard that will cover all the grid automation, of course Joe 2, but also Joe 3 and 4. Next slide, please. Before to go to next presentations, more oriented to the pilot test that have been performed last year, we can just show you the way we are working. We have, as we have said, developed the interoperable specification for ATO over ETCS in Joe 2 in this case. We built prototypes. We have realized reference test benches in Germany and Belgium, as we have said. To demonstrate and to test the interoperability of the specification, and already at this level in 2019, we have discovered several findings permitting to identify that sometimes the different suppliers interpret differently the requirement because we have to be more precise or there are missing requirements. So we have already introduced several change requests to discuss with ERA to upgrade these specifications according to these findings. And last year, we have also realized pilot tests in UK and Switzerland, and we are following the same process exactly. We analyze for the moment the findings with the different suppliers and users, and we are preparing change requests to be discussed with the agency in order to include all these improvements in the TSI 2022. Thank you. I give you the floor, Bettina.
Thank you very much, Benoit, for your presentation and this technical introduction into the technical background of the ATO. Now, please welcome with me Catherine Stowe. She is a senior engineer within Network Rail's technical authority, and she's supporting the introduction of ATO over ETCS into the Great British Railway and its development within Shift2Rail, and she was leading the testing in the UK last year. Please, Catherine.
Thank you, Bettina, and thank you, Carlo and Benoit, for the introduction to Shift2Rail and ATO. So I'm Catherine Stowe from Network Rail, and as mentioned, I've been heavily involved in the achievements of the ATO over to ETCS pilot line testing, and I've also contributed to the ATO over ETCS specification development that's being done within Shift2Rail. As you've already heard, interoperable ATO over ETCS specifications have been developed over a number of years by a group of experts within Shift2Rail who have steered the development to ensure the specifications meet the needs of the railway and that the solution can be feasibly produced. So why did we test the specification on a live railway? The reason came from lessons learned from the development of ETCS. As ETCS was implemented on railways across Europe, unforeseen issues with the specifications cropped up. This highlights the need to rely on more than just the input of ATO experts, and that we need to validate these specifications through testing as many operational scenarios as possible before they are published. By introducing the complexities of a real railway environment, we can really put these specifications to the test. The following slides will take you through the steps we took, as shown here, to gain feedback for our European ATO specifications before they are published by the European Railway Agency in 2022, as Benoit's outlined. The approach the Shift2Rail project took was to carry out as much testing as possible in the lab, and then to focus on more complex integration tests on the test track over wireless communication. The obvious first step to validating the specifications, whether in a lab or on the track, was to build prototypes according to a baseline of the ATO specifications. The suppliers involved in this piece of work, namely Thales, CAF, Azure Day, Alstom and Siemens, provided working prototypes that conform to the interoperable subset versions we agreed would be the baseline for our tests, which are listed on the screen there for you. As Benoit mentioned, ATO prototypes were tested in a lab environment first, but I'll go into this in slightly more detail. Alstom and Siemens both provided a test environment for this purpose, using their own compliant ETCS onboards and simulating a 60-kilometre track layout with 16 stations, 5 parallel tracks and balizers spaced throughout, an RBC and interlocking, a TMS, and of course train and driver behaviours being simulated. These test systems were connected through Ethernet cables, and while much of the environment was simulated, the prototypes and the ETCS onboards were real equipment. The ATO prototypes provided by the ATO suppliers were tested in different combinations to demonstrate the interchangeability of the solution. Each combination ran through a defined set of test scenarios built from agreed operational scenarios. These are the core scenarios that we use to actually build the ATO specifications. And the picture shown here is of the team presenting their reference test benches at a Shift2Rail event in 2019. Over 2 weeks of testing, 17 test cases were performed covering a range of day in the life of a train scenarios. These range from testing a start of mission scenario to the response of the system when there was an unexpected disengagement of ATO. All of the tests were passed by at least one pair of suppliers, demonstrating that fundamentally the specifications worked. The table shown here gives an indication of how many of the 17 test cases were passed by each supplier pair. As you can see, 7 test cases were passed by everyone, showing that the specifications relating to scenarios such as stopping at an ATO stopping point, disengaging in the event of an emergency brake, and the driver deciding to disengage ATO could be easily interpreted by suppliers and that the design worked in practice. 5 test cases, including the transition into ATO and respecting neutral zones, were passed by the majority of supplier pairs. However, there were a few that did not fully achieve these. In the case of engaging ATO, one supplier did not build their prototype in accordance with the clause that requires that the traction lever is placed in neutral. This was a very straightforward fix for this supplier. The other example I mentioned, respecting neutral zones, where the ATO must not request traction inside a defined area, it was discovered that the specifications do not fully clarify the expected behaviour and we required adding in additional clauses. So this feedback went into the ATO working group for implementation. 4 test cases were passed by half the pairs. One example resulted in the train being stopped before entering an ATO inhibition area, instead of transitioning on the move to manual operation. This was acknowledged as a misunderstanding of very clearly defined clauses in the specification. And finally, only 1 test case was failed by the majority of suppliers. This was mostly down to a misinterpretation of the behaviour at the last stopping point of a journey. Again, these misunderstandings could be easily rectified by suppliers and highlights how testing in a lab environment before taking the prototypes onto a test track was the right and intermediate step to take. And overall, most failures were due to easily remedied non-compliance with the specifications or a misunderstanding of the specifications requiring the working group to improve the clarity of some clauses or the addition of more requirements for clarity. These tests were clearly an excellent foundation for proceeding into the pilot tests and provided many useful pieces of feedback for the ATO specifications. We will now take a look at the pilot testing undertaken at Network Rail's ETCS National Integration Facility, known as ENIF, located in Hertfordshire, UK. ENIF is a 7-kilometre track section of the operational railway that doubles as a test track. It's fitted with ETCS Level 2 and GSMR with GPRS capability. The supporting trackside equipment required for testing, such as the RBC, Traffic Management System and ATO TMS interface unit, were provided by Siemens, along with ATO track data detailing the layout of ENIF. Alstom provided the train integration equipment, which included an ETCS onboard, an ATO to ETCS integration unit and an ATO to train integration unit. Design of the ATO to train integration unit required expertise from the Alstom team and our Network Rail train fitness and maintenance team, as connecting the ATO to the traction and braking system in our Class 313, an older type of train with a 3-notch traction and brake lever, required some unique design solutions. It shows you a diagram of the subsystems needed for pilot line testing. The main difference between an operational ATO over ETCS system and that used for the pilot line testing was the integration equipment inserted between the ATO and supporting test equipment. This was done so that different ATO prototypes could be easily interchanged during testing. You can see from the zoomed in diagram that the ATO integrates into the train through a train interface unit, which can communicate with the Class 313 specifically. We use baseline 340 with an adapter, as ATO over ETCS will be published for baseline 360. Likewise, integration into a TMS was achieved. The TMS was a bespoke creation that contained the features necessary to produce journey profiles for the ATO system. The RBC is controlled by a control system simulator, a signalling control system specifically for the ENF test track. During the test, we operated the TMS and the CSS separately. The diagram also highlights the people involved in our testing. A professional driver was required to perform test steps such as engaging and disengaging ATO. We also had a qualified tester on board who managed the safety of the tests and engineers on board the train. On the track side, we had a signaller and tester who set routes for the test train and monitored the safety of the tests, working with engineers in the control room and the tester on the train to run the tests according to our predefined test plans. These test plans outline the steps required to run through various test scenarios. For the pilot line testing, we ran the same test cases as the reference test bench, but these were grouped into 5 test runs down the test track. Each covered multiple ATO functionalities, this time testing a real product over an air gap using GPRS over GSMR in a real railway environment. We were also able to understand the integration of equipment onto the train and likewise the integration into a traffic management system. Prototypes were tested in different combinations than those in the test bench to again demonstrate the interchangeability of the solution. In addition to the time spent integrating ATO equipment on the train and the trackside control room at ENF, there were 2 weeks testing per supplier prototype combination, an Alstom ATO onboard with a Siemens ATO trackside and an Azure ATO onboard with a Thales ATO trackside. All of our test scenarios were successfully completed by all the supplier combinations, which was a fantastic outcome. Tests demonstrated that the specifications are interoperable, interchangeable and fit for purpose on a real railway environment. But as with any testing, there will always be improvements identified. As we had 4 weeks on track, some duplicate test runs were required after issues were found during initial attempts. These issues ranged from problems with the messages to and from the train, the ATO onboard not operating in line with specifications, to problems with the support test environment, such as the loss of communications. To take advantage of the time we had on the test track, running software changes were made by prototype suppliers, eliminating non-compliance issues and leaving only feedback related to the quality and clarity of the ATO specifications. To provide more detail on the specification improvements I've just mentioned, we ended up with 2 main pieces of feedback. The first came from the use of our test track in both the normal and reverse direction. When travelling down the track in reverse, we identified a mismatch in the position report provided by the ATO onboard and what the ATO trackside expected to receive. The onboard was counting its direction from the opposite datum point to the trackside. The testing group realised we needed to clarify the datum point for status reports when travelling in an SP in reverse, as although there is a clause in the specifications that defines this, there is currently room for misinterpretation in the language used. Finding issues like this is a huge reason why the pilot line test is so important, as finding out such a mismatch in position reports during the implementation of a project can be costly and time-consuming to resolve. Another example of specification feedback found occurred when the ATO exceeded the speed profile set in the ATO track data, but still obeyed the higher ETCS speed profile required for safety. This highlights the need to align speed profiles sent to both the ATO and the ETCS, and that the specifications need to make it explicitly clear which ATO data is there to inform the operational speed profile for the ATO to follow and which must be strictly obeyed. Again, while this information is described in the specifications, the intention of the clause is understood by everyone involved in the Shift2Rail development. It is clear there's room for misinterpretation when a product team goes to build their ATO equipment. We found that in the pilot line, all scenarios were able to be successfully completed versus the reference test bench, showing an improvement in understanding of the specifications by the suppliers, but also that the specifications worked in the real world. While our pilot test can be considered a success and have brought confidence in the ATO over ETCS specifications, we did have to overcome some noteworthy challenges throughout the test campaign. The COVID-19 pandemic added delays to our test schedule, requiring extra safety precautions such as masks and social distancing, and made travel to the UK more difficult. The Class 313, an older train only used for testing purposes, experienced some maintenance issues that were readily rectified by the amazing maintenance team in the Eastleigh depot. GSMR communication network with GPRS capability is a test network and required some configuration tweaks, and on a couple of occasions failed us during a shift. Fortunately, our team worked around this. Another incredible feat was that coordinating the ATO pilot line test with the freight testing activity you will hear about later today. These tests use many of the same suppliers and even the very same people. So transitioning between testing in Switzerland to testing in the UK meant we had to plan and execute the tests very precisely. And finally, Mother Nature threw a few hurdles in front of us. Testing in autumn and winter led to low adhesion conditions, fog and cold weather. Incredibly, all of these challenges were overcome due to the people involved, their commitment, flexibility and hard work. So now that our testing is done, there are some clear next steps. The first is to summarise our findings in a test report that will be published as deliverable of the Shift2Rail ATO development project. The second is to implement the feedback gained into the subsets, and both of these activities are currently underway. And then the final step of our project is to see the publication of the ATO over ETCS specifications in the CCS TSI 2022, a document that we can now have great confidence in thanks to the testing undertaken both in the lab and on the test track. Now proud to share a video that will take you through the journey we all undertook to perform the pilot line testing. This is a joint development project within the Shift2Rail development program. So it's a lot of different railways and railway suppliers coming together to develop ATO over ETCS specifications. And then what we've done is build prototypes against those specifications, and we're installing them now on this test train.
Le programme ATO est le pilote automatique des trains. Donc l'ATO a différents avantages. Tout d'abord, il nous permet d'arriver à l'heure. Son deuxième point, ça va être aussi de permettre d'économiser de l'énergie, parce que comme il connaît parfaitement la voie, il va pouvoir arriver à l'heure d'une manière intéressante d'un point de vue énergétique. Comme nous n'avons plus le côté humain, nous pouvons aussi augmenter le nombre de trains par voie. Et aussi, nous diminuons les commandes de traction, et donc du coup, ça diminue aussi les frais de maintenance.
My role is to install the ATO equipment, to determine the mechanical installation. The purpose is to drive the train easily. The driver has just to push on a button and then the ATO drives the train. As you can see, the train is moving and we are testing our ATO equipment.
Traditionally, a driver driving a train will brake slightly more conservatively. However, once you've got an ATO system driving automatically, you get more capacity on the line.
Ce qui est aussi important, c'est que notre but, c'est de ne pas supprimer le conducteur. Le conducteur a toujours la responsabilité de reprendre la main s'il faut. Donc si maintenant il freine, il va automatiquement reprendre la main. Il devra toujours être présent et justement on va plutôt le former pour qu'il puisse, en cas de problème, pouvoir réagir.
Our experience in ATO says that it also decreases the workload of driver and enables him to focus on the situation ahead of the train.
It's a very collaborative process. We've got different countries putting their opinions into how it should work, and then also suppliers, so they can tell us that the technology can actually be developed and that we are making the best technical solution.
We cooperate with many companies, and the target is to find the solution that is applicable on all trains and that is acceptable by all companies. The main challenge is to accommodate our device to this relatively old train, and it was done using our knowledge of very similar train that was tested in Czech Republic with very similar device.
The train should drive automated across Europe, crossing different countries, which were supplied by different railway suppliers and which were operated by different infrastructure managers without changing the equipment in the train.
Pourquoi est-ce qu'il y a autant de personnes différentes en train de travailler ensemble, de compagnies différentes? C'est parce que il y a, on va dire, 4 parties. La première compagnie, par exemple, ça peut être le train. Le train va être spécifique. Puis nous avons le TCS qui s'occupe de la partie protection, donc d'être sûr de ne pas aller trop vite ni de griller un feu rouge. Et après, il y a la partie ATO, donc vraiment pilote automatique. Et là, c'est en 2 parties. Il y a une partie qui se fait le long des voies, on appelle ça le trackside. Et eux, ils vont envoyer à l'ATO on-board pour être sûr de pouvoir arriver à temps et possible, enfin de manière plus intéressante d'un point de vue énergétique.
Prior to the testing with a real train on a real track, laboratory tests were executed. In the ATO working group, the Shift2Rail project, a test bench was specified and defined by all participants. The results of the laboratory tests were discussed together in the working group of the ATO, and some findings were worked into the specification. Finally, a field test strategy was developed, which will now be executed.
These tests run through a few stages. The first stage is installation of the equipment on the train, which is what's happening now. And then we'll take the train up to our test site and then we'll perform tests there with our kit on a live railway. This will be done in night testing, and we'll also go off and do some preliminary tests before we actually run our live scenarios. We're doing tests at night because it's on an operational railway, so we want to make sure that our customers aren't disturbed by our testing activities.
At the back here, we have our traffic management system. The traffic management system is in charge of managing the schedules. It then distributes those timetables to the ATO trackside here. The ATO trackside waits for the train to connect to it. The ATO on board connects to the ATO trackside and receives the schedule destined for that ATO on board. And the ATO onboard then runs according to the schedule that it has received.
The benefits would be a safer railway. It's taken a lot of the risk of me making a mistake, a human error, out of the equation by the fact I have to react to what the train is telling me. And if I don't, then the train will react and it will stop the train before I can have an incident, a collision, a signal past the danger.
Once we roll out these specifications, we'll start seeing ATO implemented on railways across Europe, and this will improve capacity. It will also improve reliability, and we'll see a lot more trains on the line for customers.
The ATO pilot line tests run for 6 weeks and were undertaken at Network Rail's ETCS National Integration Facility, located in Hertfordshire, England. Operational scenarios used to create the ATO over ETCS interoperable specifications formed the test cases. 6 test cases were conducted, covering a variety of ATO functions, including stopping at stopping points, powerless sections, changing route, and losing ATO operational conditions. These tests demonstrated the interoperability of the ATO over ETCS specifications by testing ATO tracksides and ATO onboards produced by different suppliers. Testing was completed at the end of 2020. All ATO equipment suppliers successfully demonstrated that ATO equipment conformed to the ATO over ETCS specifications and was interoperable. All test scenarios were passed, and the ATO over ETCS specifications were demonstrated to be functional. Some changes to the wording is needed, so the specifications cannot be misinterpreted. Findings from the tests will be input into the CCS TSI 2022, which will include a complete set of gradable automation 2 specifications.
Well, I hope you enjoyed seeing our accomplishments. I would like to thank all of the participants in the development of the ATO over ETCS specifications and those involved in the testing of prototypes. And I thank you all for your time this afternoon. Over to you, Bettina.
Thank you very much, Catherine, for sharing all these different experiences on the testing in the UK last year. Now we are coming to the experiences we have been taken on the freight testing, and I give over to Norbert Karl and Baselios Jacobs, both from the DB Cargo headquarters. Norbert Karl is leading the Shift2Rail ARCC project, and Baselios was leading the freight testing campaign in Switzerland. Please, both of you.
Thank you, Bettina. Thank you. Thank you. This is Norbert Karl, so I'm head of digitization automation strategy at DB Cargo and also chairman of the Innovation Program 5. And before Baselios, our lead engineer, will take you into the depths of ATO on the freight side, let's have a quick look at the outset, the strategy of IP5 and what we're about. So Innovation Program 5, the freight pillar of Shift2Rail, really focuses a lot on digitization automation. We see elements where the future wagons will be monitored, where the locomotives will bring data and deliver data to an asset control tower. And of course, ATO is one of the key areas for us in Innovation Program 5. So very early in the program, we set up and said we want to realize ATO for freight within IP5. And then, of course, the story was how can we work with a limited budget? How can we work with this given amount of time? What we found out is that there's a great collaborative platform that we could use, Shift2Rail, and we made it a real success, and we will show you how. So next slide. We looked at the different alternatives of how to test ATO, and of course, we followed the specification pace in Shift2Rail and said, okay, what we want to do is not do something else, but looking towards IP5 and looking towards the developments that Benoit Bienfair also has presented, we said, okay, let's take the specification, let's take what's been developed under funding, and let's test it in European rail freight and show that this output that has been funded is really worth also integrating in the freight system. So GRA2 was the scope of the Automated Rail Cargo Consortium, ARC as it is called. Next slide, and you can see that the setup is a little bit more complex. In fact, it's one of, I would say, the most collaborative projects we've seen because it really goes beyond the borders of individual consortia. So we have DB Cargo, Bombardier, former Ansaldo, now Hitachi, that started the Automated Rail Cargo Consortium. And of course, this is just a portion of what we needed. We have the suppliers then for the ATO, and we had individual discussions. We discussed with X2RAIL1, X2RAIL3, then partnered with ARC and the suppliers. You see here Siemens, Hitachi, AGT, Alstom. They all were willing to provide their ATO onboard units for the testing. Bombardier and Siemens, of course, played a big role in the integration. And the setup you will see that we've selected was a Bombardier locomotive, an existing ETCS equipped locomotive that we used. So Bombardier for the rolling stock integration. Now it's also Alstom, it still says Bombardier on the slide. Siemens for the ETCS onboard integration, because we integrated with an existing baseline 2.3OD, an existing train guard system. What we also had to consider was the track. Of course, for the track side, different talks and different options were on the table. In the end, we ended up with SBB, and the SBB as an infrastructure manager really contributed greatly to the success of this project. Let's move on to the technical setup. Just in a nutshell, we will hear more about this later from the suppliers, from Siemens specifically. But let me just say that we wanted to test the 3 key interfaces which any ATO onboard module needs. So the interface to the traffic management system, the interface to the ETCS, and the interface to the traction control, to the TCMS. So really it's like a triangle where we say, okay, ATO has to work within these 3 interfaces, and you see them here as the subsets. For us, it's very important that solutions are interoperable. Let's have a look at the next one. We started the integration on one locomotive, and here you see some of the elements. You see the two racks, the ETCS rack, including the converter that was installed to work with existing ETCS. You see the other rack that contained the other 3 ATO onboard modules, and of course you see an HMI here. It was a button box that our suppliers decided for, so we used a button box to initiate ATO. Just to give you some ideas about our timeline, we had 2 years in this collaboration. The way I've shown it started with the setup of X2RAIL3 in 2018, and then we had quite a short time really to come to a design freeze, which was mid-2019. We started the laboratory testing at Siemens, followed by Bombardier in Mannheim. In Mannheim was also the installation of the locomotive, which started in March. That was still according to schedule, and then COVID came into play. So due to travel restrictions, it took much longer to complete the installation. But initially in September, we could start our test runs after bringing the vehicle or the whole train set through customs and get custom clearance. We started on 7th September and tested until Christmas. There were some short incidences like a repair. We will hear about it from Bombardier later on, but we can say the tests have been a great success. In November, every of the 4 ATO onboard suppliers managed to initiate and deliver the basic test cases, and we could successfully end the test runs before Christmas. Now let's have a short look. Next slide. Those are some impressions still from summertime. I saw that Catherine showed some winter pictures. We have summer pictures here from the beginning of our tests in September. But let's not stay here, but have a look at the video. So we have a great video which really shows in depth what has been done. And after that, I hand over to Basilius Jakob as lead engineer.
We are in charge of providing a highly efficient international infrastructure which covers all the needs of a modern society. Humanity is currently facing a variety of challenges. One of them is the pollution through CO2 and the resulting climate change. Despite the efforts of the past years, a lot more has to be done to reduce emissions by at least 55% by 2030. A significant increase in rail transport will be one major key factor because rail transport results in 80% less CO2 emissions compared to truck transports. To fulfill the expectations, an increase of capacity, productivity and reliability of rail freight is needed. For this, the automatization of processes is key. The Shift2Rail Automated Rail Cargo Consortium, led by Deutsche Bahn, brought partners together for the integration and testing of automatic train operation. SBB, Alstom, AGD, Bombardier, Hitachi, Siemens and Thales cooperated, modifying a freight locomotive from the Trax platform in Mannheim, Germany. Despite COVID and resulting travel restrictions, the test runs were conducted successfully and enabled system tests under real operation conditions on test tracks between Sierra and Sion in Switzerland. The successful completion of testing automatic train operation is an important milestone for more rail freight in the future. We are proud of contributing our share to a sustainable future by strengthening rail freight with dedication and passion.
So, okay, now it's my turn. Thank you very much, Norbert, for the handover. Thanks for the video. First of all, I want to thank all engineers and train driver, let's say from DB Cargo, and engineers from Siemens, Alstom, RGD, Hitachi, Thales, and Bombardier that they made this happen. It was really, yeah, really my biggest respect. It was really a tough work. You're always traveling to Switzerland from all these countries, despite of COVID-19 and so on and so on. So really, I really respect that. Just to mention that, thank you very much to all of them. So what you can see here is our daily test run between Sia and Sierra, as you saw it in the video. We did 4 test runs per day because this was what we could do within the schedule. And as you can see here, we focused on stop and starting to control a freight train and to break a control train, to control a freight train with all the brake blending, without the driving side, the physical model of a freight train, and so on, so on. Why have we done that? Because we understand that in network rail tests and an SPB test, they already proved that logical the ATO is working, and we also, and this is the reason why we focused on our freight train use cases or freight train test cases, and this is what we did very exhaustively. Next slide, please. Yeah, as you already saw in the video, which locomotive have we used? We used a Trax AC1 locomotive. We had a full train set with 14 Ianuswing, fully loaded with gravel. And the overall weight of the train set was 1,274 tons, and the length was 240 meters. So it was really in a real environment, an operational environment with a real heavy train. You can do more, of course. You can do different loadings and so on, but it's maybe the next challenge we should, let's say, focus on. We should take. Next slide, please. I want to give you some numbers here just to make clear what were the environment we were here working. We had a delay of 6 months and heavy travel restriction due to COVID-19. It was already reported several times. We were running on a real environment on SBB using test slots between passenger schedule. So it was a real environment. We had a train on the front, we had a train on the back, and we had to deal how to, let's say, how to control that with delays, with not hindering the passenger schedule, with set priorities, and so on and so on. As we already said, in this commercial environment, the commercial traffic was always prioritized. That's really a challenge if you drive then between the schedules for testing. The testing phase was 3.5 months. We had 4 test runs per day, as you already described. We had everything because we started in September with heavy sun, went to the autumn, October with heavy rain, and then had heavy snow in November and December. Also sometimes minus 20 degrees during night, and everybody who's running a freight train can imagine what happened if you locomotive is stranding on the weekend and you have minus 20 grad. Everything is full of snow and you're not able to get up the pantograph and everything is super cold. Good luck with that. Total running kilometer and test, we had 1,740 kilometer. We had this for suppliers, and we proved that we had a plug-and-play solution, and this was really a big success for this train and for this TCMS system. The fastest system change procedure from our supplier was 30 minutes from exchange hardware to get in system-ready modus. That's already very nice. That's great to have it. And this is what I understand in plug and play. The ATO trackside coverage from SBB was, I would say, more than 98%. So there was really a good coverage. And therefore, it was really very good. We had always the right journey profiles and their availability. Next slide, please. To give you a number in total, we had ETCS emergency brake intervention during the ATO operation in this 3.5 months 7 times. Because, of course, we try to run, let's say, as close as possible to the ETCS brake and emergency brake, and we had 110 driver interactions. What is behind that? Some of them were due to technical issues. The other one, and this is what we should really clear, that ATO must be accepted by the human and by the driver. And this is the reason, this is maybe for me the bigger challenge, the driver accepted. And this is the reason why sometimes I would say the driver interaction was happened due to the trust or to the acceptance of the human factor, because the driver did it the first time, and yeah, they're not used to let's say to drive this, especially with freight trains. So from today, I cannot say if all this 100 time the driver interaction was due to technical issues or due to the human factor, because lack of acceptance, but it was there, and it's really difficult to analyze it from what it came from. We have an image, but it's very rough. What I also want to say that there was a continuously improvement of ATO onboard performance during the test period. So really from day to day, it was very nice to see that, very nice to work with a software developer here and with the engineers to give them a feedback, and they daily improved it. So next slide, please. Yeah, so what we can say that for the interchangeability, we could identify some inconsistent ambiguities of the ATO onboard driver task interface. Of course, it's an older locomotive integration of let's say a new technology, and it's always a challenge to integrate to retrofit locomotive and to retrofit rail. Everybody knows it if he's dealing with procurement. The plug and play has been successfully proven for the ATO onboard TCMS interface for this TCMS system. But in general, we need to find a solution for retrofit projects. I think for new projects, we are on a very good path within Shift2Rail, but for retrofit projects to realize the plug and play, what we need as we did it for this project, it will remain a challenge. That's clear for me. Then the control of train dynamic behavior application. And I think this is something very, very important. The train driver experience must take into consideration. There's still a lot of open topics where I would say, for example, the hill start how to apply the brakes, the process time of the brake, when to apply the air brake, when to apply the emergency brake, and so on, so on. It's very important for us, and it's maybe also the most sensitive topic to put now for freight, that topic into consideration and get a loop here, a feedback loop. Then we also need to understand how to deal with the performance to run close to safety critical braking curve. Rules and framework for performance are, from my point of view, for freight at the moment is missing. So we really need to understand how to deal with this to run to the limit, to the braking curve, to the safety braking curve, and also get acceptance by the human factor. Then what I also want to say that we try to understand the maturity of the specification. Is it already ready for, let's say, for freight? Let's say for freight procurement, can we already use it for freight? And from our point of view, the applying of the current specification for freight without further enhancement and lessons learned from the experience will lead to uncertain investment for freight areas. But we have to take into consideration what was the technical readiness level of the specification. So was it already ready for procurement? And we have also to take into consideration that the specification that we used at that time was from August 2018. And the goal was that specification will be continuously enhanced, improved, also by the reports from all this pilot test, as you can see here. And of course, the specification has been already enhanced and improved since 2018, so it's not stopping. So next slide, please. So this is what you can see here, as you already saw in the other presentations from Alstom and Network Rail. We're always using here the pilot testing to feed the ATO specification and to improve the ATO specification, also with the driver experience and so on and so on. And this is something that that we really need, the real testing environment, the experience from the real driver and from the real environment to get a more stability into the specification. So next slide, please. So yeah, that's the view from our RU side and from the 5.1 TD lead view, lessons learned, but more from our RU side. So what we see is if the product itself is in sufficient maturity, this can be lead for high risk for project investment and operation. Why that? Because, for example, if you still need to invest or improve the, let's say, the product to get it full in operation, on the one hand, you need a lot of, let's say, testing track and testing time and operation time, which you maybe don't have. And you also need, let's say, to put additional requirements and understand how to, let's say, for example, the driver experience included here. So this is the reason why I really want to stress two topics: the lessons learned, the driver requirements and behavior according to their, let's say, to the dynamic control and to the rules really need to take into consideration. This is for freight train. Just to talk here for freight train, it's really the most important part. Also a freight train with different loadings and with different settings of the brake process time, for example, air brake, how long they need to react. Of course, there's a UIC standard for air brake, how long they need to, let's say, to fill the pipe, but there's also a process time of the locomotive itself. Then the retrofit for let's say the ATO retrofit for vehicle integration remains a challenge. This is what we said for. I think we are good prepared for new trains, but for retrofit, as we did it for this locomotive, remains a challenge, and I'm sure we will find a solution here. But what I can say at the end, and this is really the most important for us to looking forward, that let's say ATO is really a game changer, and it shows already also in this project that ATO will deliver a significant potential for improvement in rail freight in terms of efficiency, operational quality, operational scalability, and to get more stability into the traffic, and for that also to increase, let's say, the freight traffic in the future. And it's the reason why, yeah, want to go to my last slide. So the next steps, and we have to look forward, we have to go to next steps, And here I stress again the whole, are you driving dynamic behavior? Take it into consideration. Again, try and find solutions for plug and play, for retrofit, as we did it for this locomotive. And from my point of view, I think this lessons was very good. And the field, when we have the environment where we can make this field test, it was a very good lesson. We learned a lot. I myself, I'm in the railway since 20 years, and I learned really a lot. And this is why we need this field test and why we need to exhaustively test, in particular for freight, the specification on all the systems on a real environment, and also take that into consideration for TSI specifications. So the next slide, please. So thank you very much for your attention. For me, it was very great experience, and I'm really forward to make this ATO happen, and let's say to reduce the CO2 and to increase freight traffic, and yeah, really looking into the future and to hand over a clean environment to our next generation. I think it's not anymore a question if we do it, it's a question how, let's say, how quick can we do it, and we're all ready to do it together. Thank you very much.
Thank you very much, Norbert, and thank you very much, Baselius, for this insight into the testing in Switzerland. Now we come to Andrea Mazzone. He is Innovation Manager and R&D Coordinator for the freight ecosystem at Bombardier Transportation. And he is in Shift2Rail, the Bombardier representative in the IP5R project, as well as participating in some other autonomy projects. Andrea, the floor is yours.
Thank you, Bettina. Thank you for the introduction, and good afternoon and welcome also from my side. It's a pleasure to be able to talk about our experience, our vision, our feeling about this project. I must apologize. I'm connected by phone due to a technical problem. We had a shift from Bombardier environment to Alstom environment this weekend. My Teams doesn't work. But the phone hopefully is good and you can understand me well. So let me start with listing our objectives, our responsibility, our goals on the introduction slide. So we as Bombardier were responsible for integrating all the ATO related components into the Bombardier locomotive. We heard it's a BR185 locomotive. It's an old locomotive. We were building this locomotive between 1999 and 2005. So a long time ago, and this gives also a clear image that TCMS is definitely not up to date. It's not the state-of-the-art TCMS that you would find on a new locomotive, already ready for automation. But it's a standard mobile locomotive, 300 kilonewton. It's widely used. I think we sold almost 400 of these locomotives in these years, and Deutsche Bahn has a quite large fleet. Important is it is equipped with ETCS 230D, and Stephanie from Siemens will give more insight to that, and this is an important point. So our main activities were, of course, in preparing all the documents, drawings, schematics, everything that is required for the integration of the components, to write the system change reports relevant for getting the authorization at the end. At the very beginning, we were involved in discussions with BFA together with the partners. We explained how we want to approach the challenge. We explained that we will not change the safety relevant systems on the locomotive, that we will install the additional equipment as piggyback solutions. Of course, main activity was the integration of the ATO as such with the subset 139. Basilius already said that it is a challenge. It is an old locomotive. It has old TCMS. The subset itself is not rocket science. I'm sure that on new build locomotive this will be straightforward. But integrating the functionality done in the drive, in the traction and brake control of an old locomotive, that's definitely a challenge. Of course, as Bombardier, we have been involved in all the activities, starting from the lab work, and then accompanying the the static and dynamic commissioning and the test runs. On the next slide, you see the Gantt chart. The project started much earlier than it was mentioned also by Norbert. So we had the vision already in 2015 when we started to write the application for the ARC project as such. But it took us a while to get the project set up as it is today with the partners on board as it has been presented. So basically the work started in 2019. And you can see here that the most challenging or the most time-consuming activities were the adaptation of the ETCS, and I will come back to that, and the development of the ATO onboard module. And then you see that these activities were followed then by the integration first in the lab, and then the installation on the in Mannheim, so on the locomotive, doing static and dynamic tests. And last but not least, by the different test cycles and the demonstration phase. All in all, a few years of project, and you can imagine this is not. It's an activity that definitely requires that much of time. When we talk about the integration of components or of functionality, we usually talk about three types of integration. It's the functional software-based one. You see that on the next slide, TCMS integration, and of course also mechanical and electrical integration. And on this slide, you can see the TCMS architecture of our locomotive, and you also see which components were added and which were modified. It's all on the left bottom corner. The yellow boxes show all the components that were added. So we have the ATO mobile gateway, we have the ATO DMI, we have the ATO onboard computers, and we have the new converter. And we also show that ETCS had to be slightly adapted. Not the safety relevant part, and I think this is also the winning criteria in the overall setup, is that we were able to get our Siemens to implement after that ETCS in such a way to keep all the safety relevant part untouched. And of course also the remaining part of the locomotive. On the next slide you see the mechanical and electrical integration, and it shows that also if we have only a few components, there's still a lot to be done. Analysis of the cableways. You want to use this locomotive for a certain period of time. You don't want to have cables lying around. It needs to be done in a safe way. You see at the bottom left side the ATO main switch, and then the functional buttons that Norbert already introduced, and this ETCS cubicle with all the components. You can see that there are many connections, many cabling, and this needs all to be planned in a good way in order to have a clean setup and also set up ready to be analyzed should error or problems happen. And this is also the case. Our next slide shows some of the challenges we had during the project. I think it's normal to have problems in these kind of projects. Some are easy to be solved, like a DMI that goes blank, and then you need to replace it. We did not have always replacements, so we were losing some time having not the displays on board. But we also had some tests related to safety relevant functions, like the ZUP acknowledgement button that during the start of mission did not work or the malfunction of a brake valve during the start of mission. We found out at the end that it was linked to the LCD ZUP brake test and to new software patches that we uploaded. And we also had a wrong addressing in the MVB register that led to instability of the MVB. And it shows that failures are part of these kind of projects, but it also shows that you need time to solve these problems. You need to plan time enough, reserve time to be able to solve eventual problems. In fact, we tried to make software patches. They seem to solve one problem but created other ones. But we also realized that when pressure is high, finger pointing starts to happen, and it does not really help. The project showed that troubleshooting needs to be done with all the partners involved, and sometimes even with partners that are not strictly connected to the project. Like in this case, Knorr, we had problems with the brake valves. but Knorr was not involved in this ATO project, but needed to support us. All in all, it resulted in a total delay of 4 to 5 weeks. It seems to be just a short time compared to the overall project time frame, but considering that we had reserved time slots on the track, that the locomotive was available just for a certain period of time, the pressure was very, very high. Well, let me conclude on the last slide in a nutshell. The project, it has been said also by Norbert, the setup is very complex. It has been involving all the stakeholders of the vertical from the industry with routes all over Europe, the operators, the infrastructure manager. It brought together 3 consortia, all consortia independently funded with collaborations agreement. It spanned over a longer period of time. It had a limited budget and also limited resources. And on top of that, of all of that, we had COVID-19. So considering all these challenges and the complexity, I would say as a locomotive manufacturing, I believe it was a fantastic engineering activity. With the mitigation of the problem solving was successful at the end. After many, many rounds, we were able to implement all the interfaces as specified, and also the interchangeability of the ATO onboard modules. And Basilio said that, plug and play. If you are able to replace a component in 30 minutes in a locomotive or in a train, then you really have a plug and play solution, as much as I understand. And it was a fantastic teamwork among the industry, and I love to be part of this project. I'm at the end of my presentation. Thank you very much, and have a good afternoon.
Many thanks, Andrea, for this overview. So now we come to Stefanie Waldmann. Stefanie is ATO project manager at Siemens Mobility, and she was leading the work package of the supplier side for the ATO over ETCS components, which were necessary to be implemented for this ATO for freight demonstrator. Please, Stefanie.
Thank you, Bettina. Good afternoon, ladies and gentlemen. I want to give you some more details for the ATO. The ATO is known as an automatic train operation module to make driving safe, efficient, and reliable. The aim of the ATO module is to fulfill operational timetable in the most efficient way by calculating the ideal speed profile for the train and by controlling the traction and the brake control of the locomotive. The X2RAIL3 Work Package 10 ATO over ETCS has the main object to test the X2RAIL1 subset and extending to the context for freight. That means X2RAIL1 was about the development of the specifications and the developing of prototypes for the test bench and for the pilot line tests. Work Package 10 had to extend these pilot tests to rail freight. This demonstration has to be carried out in a cooperation and coordination with the above-mentioned IP5 ARC consortium. It's already mentioned by Basilios. The objectives of the Work Package 10 are to develop an adapter for the connecting of the ATO onboard units modules with a test locomotive, to configure the ATO for itself, support the vehicle integration, and run the demonstration. To reach the Work Package 10 objectives, it was necessary to integrate the developed solutions into a ETCS baseline 2 vehicle called Trucks AC1. Provided and prepared by the ARC consortium to demonstrate the defined test scenarios with a freight train on Swiss railways in a real operational environment, developed specifications and scenarios from X2RAIL1 we have reused. The overall architecture and changes of the vehicle were agreed in a joint specification created between the X2RAIL3 and the ARC consortium. The work package 10 delivered the ATO ETCS solution, including the adaptation of the existing ETCS baseline 2 and the provision of an ATO adapter to connect the ATO onboard unit to the existing ETCS system. The IP5 consortium, means the ARC project, delivers the ATO trackside from the SBB and adaptations of the locomotive and input for freight scenarios. On the next slide, you can see the initial ETCS architecture. From the locomotive, it was composed of a system based on the ETCS baseline 230D, and unfortunately it was not prepared for any ATO installations. The schematic of the architecture is shown on the left part of the figure you can see. And as mentioned, the ETCS baseline does not have any interfaces for an ATO connection, and therefore it needs to be adapted to allow the ATO operation on the vehicle. Due to that, modifications of the vehicle and the ETCS system shall be as minimal as possible, and we needed to develop an approach to generate the necessary ETCS interfaces without changing the ETCS system. The final ETCS system with the ATO architecture, together with the right side of the slide, is based on the ATO over ETCS specification that were available at the beginning of the project. That means we are talking about the subset 125 and 126 and subset 130 and 139. To be able to connect the ATO onboard unit to the ETCS, it was necessary to develop the converter logic, as you can see in the gray box. And this one gets us information from the existing MVB interface without being logical part of the bus. That means that this part, the core part, only reads. And this allows the reactionist integration of the component without interfacing the existing communication. On the next slide, you can see it a bit more detailed. It's the Ethernet architecture and the Ethernet architecture for the ATO relevant communication. Each ATO onboard unit was connected to the ATO switch via some cables. This means when changing the ATO onboard unit, the used ATO onboard unit, the cable needs to be disconnected from the last and used to the new one. The provided ATO switch is a fixed part of the ATO adapter and from the whole ATO onboard rack, and the switch is unmanaged. You cannot is unmanaged, and you can connect up to 6 Ethernet communications partners via the connectors, and the cap switch was located in the driver cap and connected with the ATO switch. And it provides possibility to connect the mobile router, the ATO DMI, as well as laptops for some diagnostic or developer purpose. The ATO switch is connected to the ATO adapter on the left, the ATO onboard unit on the right, and to the cap 1 and to the cap B below the switch. The switch cap can be connected to the mobile router. In this case, the mobile router is from SBB, to the ATO DMI, and to the developer laptop. Each ATO DMI was connected to the switch using the same cables. This means when we change the ATO onboard units, we connected the ATO DMI will be exchanged, and the ATO track side will be connected via the mobile router provided by the SBB and connected via the cap switch, and the ATO adapter was physically connected to the ATO switch inside the ATO adapter. Next slide, please. The work package 10 consists of several working tasks to cover the different activities. Two of the tasks was to cover the integration of the ATO onboard unit and especially develop the ATO adapter for the vehicle. The first vehicle integration with the Bombardier TCMS was executed at the end of 2019 to generate an early feedback about the implementation of the specific subsets 139 and solution prepared for this project and to achieve a better understanding of the TCMS behavior for our suppliers. Findings were jointly discussed and between all the suppliers and also Bombardier, and the results were feedback into the MVB specifications. After that, the vehicle integration was done together with the ETCS integration. Main objectives of this step was to ensure the correct handling of the vehicle under ATO control, and therefore the connection and the communication between ATO onboard units and TCMS was checked for the correct interpretation of the data and to learn about the behavior and to control of the vehicle, including including the delay times. The ETCS integration shall ensure that the correct receiving of the subset 130 informations from the ATO adapter, and the adapter was pre-integrated within SMO ATO onboard unit during the development to ensure the compliance with the specification. And this step ensures the correct understanding for the implementation and the correct dynamic behavior with all other ATO onboard units from the other suppliers. Let's go on the next slide to the results. There are still some topics left that will be not able to solve due to the age of the vehicle, but finally all integration tests were successful and it was possible to control the train, the whole train, and sometimes only the locomotive via the ATO onboard units. And also part of this integration step was to test the ATO trackside to ensure the communication via the provided LTE mobile router is working for every supplier. On the next slide, we are at the dynamic tests in Switzerland. Finally, we start our testing in September 2020 in Switzerland. The dynamic tests were done during the commercial operation on an SBB ETCS level 2 line between Sion and Sierre with a starting point in Brick. Testing during an operation needs a special awareness. The SBB passenger traffic has always priority and the operation schedules are not allowed to be interrupted or influenced. The train needs to let pass the SBB passenger traffic and sometimes we have to wait in a parking slot. As you can see in the picture in the middle, the direction to Brick where it's with its parking slot, with the parking area of the locomotive in blue. The red one is the Brick station and the yellow one, here you can see the slot for our ATO test train. And as Basilius already mentioned, the demonstration run was with a fixed train consists including the locomotive from Bombardier and 14 Ianos wagons loaded with grid. And the whole train had an overall weight for 1,274 tons and an overall length for 250 meters. The ETCS system with a European Whittle computer on board ensures a safe operation at any time and fully independently from the ATO onboard system if the automated driving mode is supervised by a driver on board. We talk about the grade of automation 2. Maybe you know it under the name GOA 2. Let's go on the next slide. The ETCS network infrastructure was provided by the SBB in Switzerland to ensure the communication via the provided LTE mobile router is working for really every supplier. Initially, it was planned that the test drivers consist of 2 test runs, 2 weeks with 5 days, and 1 demonstration run, 1 week also with 5 days for each supplier. Unfortunately, we were in face of some challenges like COVID or some issues on local, and due to the restrictions, due to the travel restrictions, we had to postpone our testing from April into the September of 2020, and there were some issues on local that we lost some test time. To rescue the test time, we create a 1-day test script, and we unfortunately had to reduce the test time for every supplier. Let's go to the next slide. Most of the driving tests were successful. There were some test cases when the test time was not sufficient for the supplier, or one supplier had technical problems with the proper control of the train consist. We create together with the SBB and the ARC consortium a list of findings to show open points and to hand it over to the X2RAIL4 project. From the view of the signaling supplier, the tests of ATOs were really successful. When we have a look on the technology readiness level, we have really quite good results. The TRL is a standard for development technologies and shows a scale from 1 up to 9. And it's consequently used since 2014 in the EU Horizon 2020 program. And after the work from X2RAIL1, the laboratory testing, integration into the vehicle, we demonstrated the interoperable interfaces between the ATO onboard, the ETCS system and the TCMS system during a commercial operation in Switzerland, and show the interoperability of the ATO systems. That means that it's possible to interchange the ATO onboard units by different supplier, e.g. Alstom, AGD, Hitachi and Siemens. And I guess we are on level 6 when we have a look on the TRL. And from signaling point of view, the work package 10 was a really great success, and we are on the best way to lift the ATO up to the next level. And I guess we will do it. And thank you for your attention. Thanks for listening. Thanks for your time. Bettina, now back to you.
Stefanie, many thanks for your presentation and for giving an insight into the suppliers' experiences on the testing. We come now to Jack Schneider. Jack Schneider is at SBB, Head of European Standardization ATO and CCS, and he's representing SBB in the ATO work packages in Shift2Rail. Please, Jack, the floor is yours.
Thank you very much, Bettina. Good afternoon, everybody. I will, please, next slide. I will give you some overview about what's the future of ATO. The previous presentations showed already the status of the GO2 specification. After passes of the specification have been established, some proof of concept with this specification by the Shift2Rail consortium, but also by another railways like SB together with CNF, Siemens on a regular operated existing level 2 line, regional line have been taken place. The ATO, next please. The ATO specification is currently mostly completed and agreed together with ERA for the publication in the TSI 22. This is the great and major milestone for the automation in the rail sector. Together with the ETCS upgrade and other and ATO specification in the TSI 2022. The first specific lines, mainly new lines with new vehicles, can be planned and implemented. The specification for the GO3 and 4 system are defined in a draft form and are currently being reviewed of the full Shift2Rail group up to the end of this year. From the beginning of 2022, this draft will be discussed with ERA, and it is currently expected that the technical specification for the autonomous rail operation will be available from mid to end of 2023. This will be then the next or another major milestone for the competitive European rail system. Next slide, please. Shift2Rail ATO work and specification are the foundation and the basis for an ATO application, but only together with the large architecture programs RCA, Reference CCS architecture, and Agora, Open CCS onboard reference architecture, large-scale and effective implementation can be made. However, this also requires unified operational concepts, unified functional systems architecture, as well as migration plan. The new digital railroad service is to be realized with the help of the program System Pillar and Innovation Pillar in the coming years. The European Commission has officially announced the successor of the current Shift2Rail Journey undertaking, Europeans Rail Journey undertaking, as part of the proposal to would see the creation of 10 new European partnerships under the Horizon program. European Rail Undertaking will build the work done by Shift2Rail and work with these members and partners to ensure that the innovative technologies are developed and deployed more quickly. The joint undertaking will focus on digital innovation and automation to give the rail sector the radical transformation it needs to achieve the European rail objectives. Next. What's next? With the TSI 2022, each railway must consider and also define how and from when ATO should be used. Already today, several railways preparing corresponding rail rollout plans by also implementing ATO on national train protection systems for a better migration. The following issues has to be taken into account during the realization. Goal of ATO GO2, punctuality, capacity, energy savings, infrastructure characteristics like ATP, ETCS full supervision, single lines or nodes, new lines, mixed traffic, or uniform business areas like passenger traffic or freight. Characteristics of the vehicles to be equipped. Do existing vehicles also have to be taken into account, or will only be new vehicles be procured? Then the traffic management system. Does a traffic management system exist? Is a driver assistance system already in use and established? Will there be a transition from ATO to driver assistance, or is it complete ATO operated? And nevertheless, the staff. Training of all involved staffs and drivers has to be prepared, as well as people in the operation centers and in the maintenance. All these factors will determine the scope and also the benefits of ATO. At the same time, the specification must be further developed according to the open points and findings from the pilots. Other specific areas of application or use, such for maintenance vehicles of the infrastructure manager, must be covered. However, this also requires European harmonization operational processes, especially in the application of ATO for freight sectors. As soon as ATO is applied, even more optimal fine-tuned control solutions between punctuality, energy savings, capacity can be established. With the GEO 3 and 4 work, European operational harmonization becomes mandatory. However, in the studies of increasing productivity with GEO 3 and 4, legal issues, liability, and ethics must also be analyzed. Already with the use of an operation of ATO, the railways can realize a number of improvements and cost savings. With ATO, punctuality, customer satisfaction, ecological basis, cost saving, productivity, safety, as well as employee satisfaction increases. The main benefit is realized on both sides, infrastructure and railway undertaken. For the railway undertaken through energy savings and precise stops, and for the infrastructure manager to the increase of timetable stability and later the capacity. In the next phase with the automation grade 3 and 4, a high benefit results from the significant higher productivity in the rail staff of railway undertakings. Please next. There is still a lot of work that can only be done between railways and industry and requires continuation of the work shared under the Shift2Rail with the collaboration of RCA and Agora and the new planned system pillar and innovation pillar. Many thanks for your attention and have a good afternoon.
Thank you very much, Jack, for giving us a view into the future on the ATO topics. This was also closing the presentation section of the webinar, and we are coming now to the Q&A session. And I would like to pass over to Alice Hickman. She is responsible for IP2 at Network Rail, and she will guide us through this Q&A session. Please, Alice.
Good afternoon, everybody. So I'm not sure if you'll have seen, but on the right-hand side of your screens, there is an opportunity to post questions to our presenters. I know we are quite tight for time this afternoon, so if we do not get the opportunity to answer your question, the questions will be answered offline and shared with all those registered for the event. So I'd like to kick off with a question for Benoit. What is the main difference in functions between ATO in the Metro CBTC train and the ATO in an ETCS train?
So CBTC is dedicated to urban application. It covers ATP train protection, and ATO. It is used since decades in urban application by most of us. And to be honest, most of us also, we started from the ATO, from urban application coming from CBTC to enlarge to mainline application. The main difference in mainline application is that first we use ETCS for the interoperability reason, and the ATO has also been changed, starting from urban application, to be interoperable. That is to say, to have a standard interface between track and train to permit interoperability, with the other suppliers. Another difference is also the fleet, the diversity of the fleet, which is not the same in urban application. They have the same type of trains for one application, while in mainline we have to cope with a different type of low-cost trains and so on. And finally, the last point which is different is the line complexity. So the interconnections between lines in mainline's application is different. So we started from ATO for urban application and enlarged to get interoperability and to be connected to ETCS.
Thanks for that answer there, Benoit. I've got one here for Catherine. So for Catherine, have the tests been pushed at the limit of the systems, such as low adhesion, stopping accuracy, degraded mode, and finally, drivers give feedback of their feelings about ATO operations?
Thanks, Alice. So the tests were mostly focused around testing interoperability and interchangeability. However, some of the responses that we expect from the ATO system need to be harmonised. So, for example, there is a low adhesion response already built into the ATO specifications that we did test. And so that's where if the train is advised of a low adhesion area ahead, it will adjust its braking profile accordingly and reduce its deceleration rate there. However, I wouldn't say we pushed it to the limits. So the scope of this test really was around checking that everyone's interpreting the specifications the same, and that we will have universal response by everyone. But those fine-tuning of performance would be things that we would like to see done in future, which I would say would be done in the further development stages for an application, a specific application. Stopping accuracy, for example, we had a pretty large stopping accuracy for our tests because we weren't focused on that performance there. However, different railways will have different needs. If you're in a metro environment, you might need to have very high stopping accuracy versus a train that's in a different environment. So we didn't actually test that, but I would say that's certainly something we'll see getting tested and feedback coming back when we start to apply the technology. Finally, driver feedback. So as you heard from the freight testing, there was a lot of driver feedback. In our testing in GB, we also had a lot of discussions with the drivers. And so we had very good acceptance of ATO from our testing drivers involved. But again, that wasn't a specific point of feedback. This was mostly around the functionality.
Thanks for that, Catherine. We'll move over to Norbert next, please. How can ATO master the experience of train drivers?
Thanks for the question. Okay. When developing ATO, I think we're talking about a great tool to assist train drivers in their daily business. So we really need to look closely at the driver tasks. Yeah, what are active tasks? What are passive tasks? When the driver monitors a freight train coming towards him, he's also looking at the load, and those are some of the passive tasks. So therefore, as a general statement, the role of the driver needs to be in the center, and we need to put a lot of drivers in these test setups and obtain their feedback. Yeah, ATO is not a technology first, I think, but it's really a whole operational regime which will need to be developed. So we need that feedback from drivers, from users. How's the usability? And I think bottom line, whether it's a GOA2 system with a driver in a cab or an automation system of the future with maybe a remote control or remote supervision function, it should definitely ease the driver's life in a way that they get ideal system support, that they get ideal notifications, and that all their actions are supported. That's what ATO is about. Yeah.
Thanks for that answer, Norbert. I'd like to move over to Basilios next. Got a question for you. The driver interaction during ATO operation, so 110 times, what percentage was due to technical issues and what percentage was due to non-acceptance by the human/driver?
So thank you very much for that question to the audience. That's maybe the main question. And I must say, honestly, I cannot answer that properly. I wish I could do that. But this is the problem that, or this is the challenge where we said this is, let's say, related to human behavior and also the technology where the human is centric on this on the centralized point around this technology or within these technologies. What I cannot tell you the number, but I want to tell you how we wrote down this interaction. So what we did, you know, it's not allowed to talk with a test driver during the test, but we analyzed that different drivers had different understanding how to run the train, and maybe this is a challenge. And this is the reason why we try to, let's say, to understand what the driver is doing within his habits. For example, if you're running in front of a switch, to understand why is he now interacting, because the brake, for example, is taking too much kilonewton or the emergency brake, or is not applying the air brake too early enough, and so on and so on. This is something where every driver was a little bit did it a little bit different. Also, because they say now we have loaded gravel, we don't have loaded liquids. Others say if we have gravel, it's pushing a lot, and so on and so on. So to summarize, this number comes after the debriefing with the driver every day to understand how much interactions we wrote down and how much interaction they had from that feeling. And I wish I could answer this question, but I can't do that because this is something that we need to refine in the future to understand where was the issue and what is the role of the human factor here, which is, from my point of view, really the main challenge in the future.
Thank you, Basilios. I'd like to move over to Andrea next, if we still have you with us on the phone. So we've got a question here. For speeds of the main line or intercity beyond 120 kilometres an hour, position errors, odometry inputs for calculation, communication latency, and the loss of communication will be a major factors for the safe operation or for the stopping accuracy. How will this be achieved? Further safety integration level of ATO software is considered.
Okay, thank you for the question. First of all, ATO is not specified to be safe to relevant so far. So we're talking about ATO over ETCS because we want definitely to have the ETCS being and remaining responsible about safety, which means that also the braking curves are being managed by the ETCS at the end. What the question I think is about is dynamics of or the real physics on the train, and this needs to be considered by the ATO. So the ATO must have the information about what is the actual status of the quality of the track, what is how does the slip slide work, etc. The precision of stopping is not something that comes from very high speed within a second. So there is always a brake curve behind, and the slower you are, the more precise the odometry is going to work, and the precision can be kept. So I don't think that speed as such is an issue about related to precision. It's more about how do you implement the dynamics and the overall calculation.
Thank you very much. Yeah. That was perfect. Thank you, Andrea. I'd like to move over to Stephanie next, please. Will the ATO over ETCS equipment and functions be interoperable among manufacturers?
Yes, thanks for this question, Alice. Yes, of course, it could be possible. The ATO can be connected to the ATO switch. The switch is integrated in the ATO adapter, and this means when the changing by the used ATO onboard unit, the cable needs to be disconnected from the last ATO onboard unit and can be connected to the new one you would like to use. That could be an ATO onboard unit from Alstom, from AGD, from Hitachi, and so on, from Siemens. That one you want to choose.
Thanks, Stephanie. And we have one final question for Jack. How do you see ATO/ETCS developing as part of the wider and deeper digital railway?
Would you please repeat the questions? I haven't heard it.
Absolutely. How do you see ATO over ETCS developing as part of the wider and deeper digital railway?
I believe ATO and ETCS development is the most important thing for taking media breaks out of the system as they can, and with the very short operation by the limits, by the sources, there will be the major issue for get any digitalization in the railway sector.
Thank you for that answer, Jack. I'd like to hand back over to Bettina now and close out the question and answer session. If there are any Q&As that have come through in the chat, we will answer those offline and send those around to all those registered for today's event. Thank you, everybody. Bettina, back to you.
Thank you very much. So thank you very much for all the participants for your attention and for giving us the opportunity to share these results with you today. Thank you also for these numerous questions, which we will then finally answer and share with you on the Shift2Rail website. I would also like to thank all our speakers for their preparation and their presentations, and not to forget all the technical teams and the partners that have been involved during the project, providing the expertise and contribution to the different building blocks which have brought these results and collaboration alive. Finally, I would like to thank Network Rail for hosting this webinar and for all the technical support and the preparation in making this event today happen. So thanks a lot, and goodbye, and stay healthy.